In this lesson, we're going to talk about the properties of algebra. The first property we want to talk about is the commutative property of addition. This property says that when we're adding two numbers, the order in which we add them does not matter because they result in the same solution. For example, I can do 5 plus 3 and get 8. If I reverse the order of the add-ins to 3 plus 5, that is still 8. If we write this using variables, this is frequently written as A plus B is equal to B plus A, where A and B represent any numbers. The commutative property of multiplication is similar to the commutative property of addition, but this time it is saying that the order in which we multiply two numbers does not matter because it results in the same solution. Remember, 5 times 3 is 15. 3 times 5 is also 15. To represent this algebraically, we can say A times B is the same as saying B times A, where the variables A and B represent different numbers. The associative property of addition. The associative properties tell us that it doesn't matter which two numbers you add together first when you're talking strictly about addition. So for example, if I had the problem 5 plus 3 plus 2. Notice that the 5 plus 3 is in parentheses, which is saying we need to add the 5 and 3 first. Well, 5 plus 3 we know is 8, and then 8 plus 2 gives us 10. So the associative property says we can change around the grouping. So suppose I had 5 plus 3 plus 2 in parentheses. Now notice that the only thing that's changed from here to here is where I've placed the parentheses. The numbers are still in the same order. I've just grouped them differently by the parentheses. So in this scenario, you would add the 3 and the 2 first. Well, 3 plus 2 gives us 5. So this is still resulting in 5 plus 5, which also gives us a solution of 10. So associative property of addition, if we want to represent it algebraically, we can say parentheses A plus B, close parentheses, plus C is going to give us the same solution as A plus parentheses B plus C, where A, B, and C represent three different numbers. Now we have the associative property of multiplication. Very similar to the associative property of addition. The difference here is we're talking about multiplication. So for example, if I had 5 times 3 in parentheses times 2, well, that would be 15 times 2, which would give me an answer of 30. If I change the grouping symbols but not the order in which the numbers are arranged, I end up with 5 times 6, because 3 times 2 is 6, but that still results in an answer of 30. So if I want to represent this one algebraically, I can represent it as A times, parentheses, A times B, close parentheses, times C, is the same as A times, parentheses, B times C. Be careful with this one because we can represent multiplication with the dot. We could also represent multiplication like this. This could also be written as AB in parentheses C, or A parentheses BC without the dot. Alright, next up is the distributive property. The distributive property is telling us, suppose if you had 5 parentheses 2 plus 4. If I solve this with the traditional order of operations method, that becomes 5 times, well, 2 plus 4 is 6, which gives me an answer of 30. But the distributive property says that we can take this 5 and distribute it over every term inside of the parentheses through multiplication. So this is the same as saying 5 times 2 plus 5 times 4. So that 5 times 2 is 10, 5 times 4 is 20, 10 and 20 is 30. Now, if you wanted to represent this one algebraically, this rule, you could say A parentheses B plus C is equal to A times B, which we can represent as AB without the dot multiplication, plus A times C. That's one way that we can use the distributive property. If we want to do a little bit of clarification, we could have also had the problem 10 parentheses 4 minus 1. So if you solve it traditionally, you end up saying 10 times 3, which gives you 30. If you use your distributive property, which you can do here, you would say 10 times 4 minus 10 times 1. So that'd be 40 minus 10, which still gives you the solution of 30. So sometimes you'll also see the distributive property is most often seen this way, but you could also see it written in this fashion. A times the difference between B and C is equal to AB minus AC. That's another way that it could also be written. So this is the distributive property. All right, one you may not have heard before is the additive identity property. And the additive identity property, we see the word additive, so I know I'm going to be doing something with adding. So let's suppose I had 5 plus 0. Well, 5 plus 0 is equal to 5. The identity property is just saying whatever you do to this number, you're still going to result in that number. The number or the quantity essentially does not change. So in the additive identity property, we are adding, it's saying that you can add 0 to any number and still get that number. The number remains unchanged. Even if you had negative 8 plus 0, remember that's still negative 8. When we write this number algebraically, remember we're using a variable to represent any number. So in this case, I'll use A, and the additive identity property is saying that A plus 0 is equal to A. So that's actually maybe something that you hadn't heard the phrase additive identity property before, but this is something that you already knew intuitively. So we're just representing what you've already known algebraically. This next property is called the multiplicative identity property. So we just talked about the additive identity property. Now if we're talking about multiplicative, I'm thinking multiplication. Identity, so I know that my answer has to result in the same number. So for example, if I had 7, and I'm doing multiplication here, 7 times something equals 7. Well, I know that that's 1. Or if I had negative 8 times 1, I still am ending up with negative 8. So the multiplicative identity essentially is saying you can take any number, let's make it negative, negative 100 times 1, take any number, multiply it by 1, and the number remains, or quantity remains, unchanged. To represent this one algebraically, we can say A times 1 equals A, or you don't have to use A as your variable. You could use X or any other variable of your choice. All right, the additive inverse property. Now, a lot of times students get confused between the additive identity and additive inverse. So when we're thinking about inverses here, this is saying, suppose you had 4. This is saying you can take any number and add to it its opposite. The opposite of 4 is negative 4. And you will get a sum of 0. Likewise, if I said negative 7 plus the opposite of negative 7 is positive 7, I get a sum of 0. So essentially, you're undoing, you're reversing. You're taking, doing opposites here is one way that you could think about it. If you had 1.6, you would have to add negative 1.6 to it to result in 0. So the additive inverse property represented algebraically is A plus, now I'm going to write negative A, and you can read that as negative A, or you can read it as the opposite of A is going to equal 0. So any number plus its opposite is equal to 0. Now this is also something that you knew from 7th grade math when you first learned about adding integers. Any number plus its opposite gives you a 0. The multiplicative inverse property can be confused with the multiplicative identity property, so we need to be cautious here. This one is saying you can take any number and multiply it by its reciprocal. The reciprocal of 7 is 1/7, and you end up with 1. A number times its reciprocal is 1. Now, some of you may be confused, what do I mean by reciprocal, so on and so forth. So let's backtrack over here for a minute. When you're talking about reciprocals, the reciprocal of a number is when you reverse or switch places the numerator and denominator. So you're looking at 7 and you think, oh, that's not a fraction, because when I say numerator and denominator, you think about fractions. And you'd be correct. However, you can take any number and change it to a fraction. In this case, 7 is a whole number. So I can change it to a fraction by simply putting a 1 under it. 7 is the same as 7 over 1. Remember, this means divided by. So it still results in 7. So the reciprocal of 7, or 7 over 1, is 1/7. When I multiply 7 over 1 by 1/7, how do I know that I get 1? Remember your rules, or how to multiply with fractions? The simplest way, you're just multiplying straight across. 7 times 1 is 7. 1 times 7 is 7. So 7 times 1/7 is 7/7, or 1 whole. If you had 8, to use the multiplicative inverse property here, I'd have to multiply it by 1/8 to get a 1. If I had 2/7 and I multiply it by 7/2, that's going to result in 1. How do I know that? 2 times 7 is 14. 7 times 2 is 14. So I end up with 14 over 14, or 1 whole. This also works with negatives. So like if you had negative 10, you just need to multiply by negative 1/10. So we already know 10 times 1/10 is 1, based on what I've shown you previously. And a negative times a negative we know is a positive. So if we want to represent the multiplicative inverse property algebraically, we are saying A times 1 over A equals 1. Or if you want to represent this or say this in words, a better way to say it would be a number times its reciprocal is equal to 1. Because the beginning number could have been a fraction. Or I could have even had 1/6 times 6 equals 1. This is also still using the multiplicative inverse property. And then the final property is referred to as zero property. And this one, you could confuse this one with some of the others if you weren't careful. The zero property is saying that you can take any number, multiply it by 0, and the solution is 0. Any number, negative 1,000 times 0 equals 0. And this is something that you already knew. Any number times 0 equals 0. Well, this is the zero property rule. So for example, if I had A representing any number I so choose, times 0 is equal to 0. There are two additional properties that I think we should talk about. The first one is the addition property of equality. Alright, suppose you had 5 plus 10. Well, we know that that's 15, and 7 plus 8 is 15. So we know that both sides of this equation are equal. Well, the addition property of equality says that you can add, if you add, let's say, 2 to the left-hand side, and I add 2 to the right-hand side, that both sides of the equation remain equivalent. This is now 17, and then this is 17. So the addition property of equality is just saying that if you add something to one side and that same amount to the other side, then your equation remains equivalent. Algebraically, it says this. If A equals C, meaning two sides are equivalent, then we know that A plus D, so if I add D to one side, that will be the same as adding D to the other side. I'll still end up with the same solution. The other property is the multiplication property of equality. So let's start off with a problem. Suppose you had 6 times 3, which we know is 18, and we know that 6 times 3 is equivalent to 9 times 2, also 18. Well, what if I were to multiply both the left side and the right-hand side by 2? Would that have any effect on their solutions? Well, it would change what both sides equal, but they'd still remain equal, because this is now going to be equal to 36, and this side is also equal to 36. So the two sides, the right-hand side and the left-hand side, still remain equal. To write this algebraically, we can write it as if A equals C, so starting off like the previous problem did, if the left side and the right side are equivalent, then A times D is going to be equivalent to C times D.